The original title of the video that came before this referred to the limit comparison being never ugly. But then I thought of this wonderful example. Let's take the sum as n goes from 1 to infinity of sine of, what shall we take? How about n minus 2 over n squared minus 3n. If I'm going to do that, I should probably start n at 4 rather than at 1. That way I avoid division by 0 and everything is happy. So, what do I do with this? Right? How do I examine this and try to get an understanding of what it does? Well, when I look at the values of n, as n gets bigger and bigger, n minus 2 over n squared minus 3n, well, that goes to 0 as n goes to infinity, which is actually nicer than most other things I could expect. If it goes to 0, then that means that sine of this value, that has a limit. That limit is 0, so I can't just use the divergence test and be done, but I can definitely say sine of n minus 2 over n squared minus 3n goes to 0 as n goes to infinity. Well, there's something that I know in terms of limits that involve sines, right? Over here, I have sine of some angle. I have sine of theta. And I want to compare it to something else in such a way where when I take the limit as n goes to infinity, well, as n goes to infinity, my theta goes to 0. I want this to give me some L, which is a positive finite number. Well, in that case, this just needs to be theta. If I can do that, sine theta over theta, that, forget L, that goes to 1. That goes to the nicest positive number. And so, that's what I need to compare my series to. So I need to do limit comparison with n minus 2 over n squared minus 3n. Alright, so limit comparison with n minus 2 over n squared minus 3n. I can do it in one of two ways. I can either say, all right, my first test will be limit comparison with that, and then second test, I can use limit comparison of n minus 2 over n squared minus 3n with the 1 over n that it clearly resembles. This diverges, therefore this diverges. This diverges, therefore this diverges. So I can create this cascade of tests the way that I used to do with L'Hopital's rule, when I would take L'Hopital, 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 and then once I have a limit at the very bottom, that translates all the way back to the very beginning. So I can do that, or I can try to mash them both into a single test. So I'll show that one, but you should be able to unravel from it what the two separate tests would look like, and I'd imagine most of you will prefer the separate tests to just one massive beast. So let's do limit comparison using 1 over n. We want to look at the limit as n goes to infinity of sine of n minus 2 over n squared minus 3n when compared with 1 over n. So this is equal to the limit as n goes to infinity of n times sine of n minus 2 over n squared minus 3n. Very well. The only thing that I can do is to use sine theta over theta. So I need to take this thing over here and I need to divide it by theta. But if I'm dividing by theta, I better also multiply by theta. Otherwise, it's not going to work out. This way I've multiplied by 1. I have not changed the value of the element itself. And so this gives me the limit as n goes to infinity of sine of blah 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 divided by blah blah blah. Sine theta over theta. That's what matters as theta goes to 0. Times whatever is left. I've got this n over here. I've got this thing over here. That gives me n squared minus 2n over n squared minus 3n. And so as n goes to infinity, this goes to 1. This is n squared over n squared. That goes to 1. And so the whole thing goes to 1. And now I can say that since sigma 1 over n diverges, how do I know that it diverges? Well, I can say it's just a p-series with p greater than or equal to 1. Or in this particular case, I can say, well, it's the harmonic series. Don't ever say it's the harmonic series test. There isn't a test for that. It's just it is or it isn't. So since sigma 1 over n diverges, so does the original series. There we go. So this is about as ugly as I can think of the limit comparison getting. It isn't terribly bad. It requires a little trick, very little more than that. It's simply the idea that we can use sine theta over theta. We can give you something that has cos theta minus 1 over theta squared. That also gives you a nice result. You just need to artificially create the limit that is going to give you something useful. And that's how we looked at the comparison tests from the beginning. We want to look at the series, at the general term that we have, and think about what does it look like? What does it most approach? So sine of theta looks an awful lot like theta as theta goes to 0. Keep that one in mind, and the rest of the exercises are reasonably straightforward.